Gazing up at the night sky, we often wonder, are we alone? This question has haunted humanity for centuries, driving us to explore the cosmos and seek out other forms of life. The vast expanse of space, with its countless stars and galaxies, holds many secrets, and among them, perhaps the answer to our most profound question. The answer might be closer than we think, etched on the surface of our planetary neighbor, Mars. This enigmatic planet, with its rugged terrain and mysterious features, has been the subject of intense study and speculation. Scientists have long been fascinated by the possibility that Mars might harbor clues to the existence of life beyond Earth. The Red Planet, as it's aptly called, has long captivated our imaginations, whispering tales of ancient civilizations and lost worlds. Could there have been a time when Mars was teeming with life, with thriving communities and advanced technologies? The idea seems far-fetched, but the more we learn about Mars, the more plausible it becomes. Could it be that our own history is intertwined with this rusty world, that humans once walked on Martian soil? Some theories even suggest that life on Earth might have originated from Mars, transported here by meteorites. This notion, known as panspermia, challenges our understanding of life's origins and opens up new possibilities for our connection to the cosmos. The idea seems like science fiction, but some intriguing clues suggest that Mars wasn't always the desolate wasteland we see today. Geological evidence points to a time when Mars had a much more temperate climate, with liquid water flowing across its surface. These ancient riverbeds and lake basins hint at a planet that was once capable of supporting life. Billions of years ago, it may have been a much more hospitable place with flowing rivers, vast oceans, and a thick atmosphere. This environment would have been ideal for the emergence of life, providing the necessary conditions for biological processes to take hold. If life did arise on Mars, it would have had ample time to evolve and diversify before the planet's climate changed. If life arose on Earth, could it have also sparked on early Mars, perhaps even predating our own planet's story? The discovery of microbial life on Mars would be a groundbreaking revelation, suggesting that life is not a rare occurrence, but a common outcome of planetary evolution. This would have profound implications for our search for life elsewhere in the universe. The possibility is tantalizing. If we find evidence of past life on Mars, it would revolutionize our understanding of our place in the universe. It would mean that life is not unique to Earth, but a phenomenon that can arise under the right conditions. This discovery would also raise new questions about the potential for life on other planets and moons in our solar system. It would mean that life isn't a unique phenomenon confined to our pale blue dot, but rather a force that could emerge and potentially thrive on multiple planets within our cosmic neighborhood. The implications of such a discovery are staggering, suggesting that the universe is teeming with life, each world with its own unique story and evolutionary path. Could Mars hold the key to unlocking the secrets of our own past? By studying Mars, we may uncover clues about the early history of our solar system and the processes that led to the emergence of life. This knowledge could help us understand the conditions necessary for life to thrive and guide our search for habitable worlds beyond our own. Could it be that the seeds of humanity were sown not on Earth, but on a planet millions of miles away? This idea challenges our perception of our place in the universe and our connection to other worlds. If we are indeed descendants of Martian life, it would mean that our origins are intertwined with the fate of another planet, adding a new dimension to our understanding of life's journey. The journey to answer these questions is just beginning, but the answers, whatever they may be, promise to be profoundly impactful. As we continue to explore Mars and other celestial bodies, we are not just searching for life, we are seeking to understand our own origins and our place in the cosmos. The discoveries we make will shape our future and redefine our understanding of life itself. Today, Mars is a dry, cold desert, its surface scarred by ancient volcanoes and colossal dust storms. The landscape is harsh and uninviting, a stark contrast to the vibrant blue planet we call Earth. The red planet's surface is a testament to the violent and tumultuous history it has endured over billions of years. But evidence suggests a very different past. Geological formations and mineral deposits hint at a time when Mars was not the barren wasteland we see today. Scientists believe that billions of years ago, Mars possessed a much thicker atmosphere, one that could have supported liquid water, a crucial ingredient for life as we know it. This thicker atmosphere would have been rich in greenhouse gases, creating conditions that allowed water to remain in liquid form on the surface. This thicker atmosphere, rich in greenhouse gases like carbon dioxide, would have trapped heat from the sun, creating a warmer, wetter environment. The presence of clouds and a more dynamic climate system would have made Mars a much more hospitable place. This warmth, combined with evidence of ancient riverbeds and shorelines, points towards a Mars that was once awash with liquid water, possibly even hosting vast oceans spanning its northern hemisphere. These ancient waterways suggest that Mars may have had a hydrological cycle similar to Earth's, with rivers, lakes, and perhaps even seas. But what happened to this once vibrant world? How did Mars transform from a potentially life-supporting planet to the desolate landscape we see today? Where did the water go, and how did Mars lose its protective atmosphere? The loss of its atmosphere likely played a crucial role in the disappearance of liquid water, as the planet could no longer retain the heat necessary to keep water in its liquid state. These are the questions that continue to intrigue scientists as they piece together the puzzle of Mars's past. Through the use of rovers, satellites, and advanced computer models, researchers are slowly uncovering the secrets of Mars's transformation. The answers, when we find them, will be crucial in understanding not only the history of Mars, but also the potential for life beyond Earth. By studying Mars, we gain insights into the processes that can change a planet's climate and habitability, offering valuable lessons for our own planet's future. The leading theory for Mars's dramatic transformation is atmospheric loss. Unlike Earth, which possesses a strong magnetic field, Mars's magnetic field is weak and patchy. This magnetic field acts as a shield, protecting our atmosphere from the constant bombardment of charged particles streaming from the Sun, known as the solar wind. Without a strong magnetic field, Mars's early atmosphere was vulnerable. The solar wind, over millions of years, stripped away the Martian atmosphere, thinning it out and causing the planet to cool. As Mars cooled, its liquid water froze, locking itself away as ice beneath the surface or escaping into space as vapor. This atmospheric loss was a gradual process, but it had a profound impact on the red planet, transforming it from a potentially habitable world into the frozen desert we see today. Understanding the mechanics of this atmospheric stripping is crucial, not just for unraveling the mysteries of Mars, but also for assessing the habitability of other planets beyond our solar system. Section 4, Planetary Cataclysm, the Great Exodus. While atmospheric stripping explains the gradual loss of Mars's habitability, it is not the only theory that scientists have proposed to explain the dramatic changes on the red planet. Some scientists theorize that a more sudden cataclysmic event might have occurred, drastically altering the planet's environment in a relatively short period of time. This event could have accelerated the process of atmospheric loss and climate change, potentially playing a significant role in the hypothetical migration of humans to Earth. One such cataclysmic event could have been a massive asteroid impact, which would have had profound effects on the Martian environment. Mars bears the scars of many large impacts, including the colossal Hellas Planitia, a vast impact basin that stretches over 2,300 kilometers in diameter. Hellas Planitia is one of the largest impact basins in the solar system, and its formation would have released an unimaginable amount of energy. A sufficiently large impact could have released enormous amounts of energy, causing widespread devastation and altering the planet's climate on a global scale. The impact would have blasted away portions of the Martian atmosphere, reducing its ability to retain heat and leading to a dramatic drop in temperatures. Such an event would have been devastating, causing widespread extinctions and rendering Mars even more inhospitable than it already was. If humans did exist on Mars at that time, this cataclysm could have forced them to seek refuge elsewhere, as their home planet became increasingly uninhabitable. In a desperate bid for survival, they might have launched a mission to the only other habitable planet within reach, Earth, embarking on a perilous journey across the vast expanse of space. This, of course, is highly speculative, and there's no concrete evidence to support the idea that humans once lived on Mars and migrated to Earth. However, it highlights the volatile nature of planets and the possibility that life, even intelligent life, might be forced to adapt and migrate in the face of cosmic adversity. The story of Mars serves as a reminder of the fragility of habitability and the resilience of life in the universe. Section 5, Scars of the Past, Evidence of a Watery History. While the idea of a Martian exodus remains speculative, the evidence for a wetter, more dynamic past on Mars is compelling. Orbiting spacecraft and robotic rovers have sent back a treasure trove of data, revealing ancient riverbeds, lakebeds, and even signs of past tsunamis, all pointing to a time when liquid water flowed freely on the red planet. The Curiosity rover, for example, has been exploring Gale Crater, a site that scientists believe was once a lake. It has found sedimentary rocks formed by the deposition of material by water and minerals like clay and hematite, which also form in watery environments. These discoveries provide compelling evidence that Mars was once a much more Earth-like place, with conditions that could have supported life as we know it. The question now is, did life actually arise on Mars, and if so, what evidence, if any, remains of its existence? Section 6. Seeking ancient life in Martian rocks. The search for ancient life on Mars is one of the most compelling reasons for our continued exploration of the Red Planet. If life did exist on Mars, even in microbial form, it would have left behind telltale signatures in the Martian rock record. These signatures, known as biosignatures, could include organic molecules, the building blocks of life, or fossilized remnants of ancient microorganisms. They could also take the form of isotopic anomalies, unusual ratios of elements that can indicate biological processes. The Curiosity rover and its successor, Perseverance, are equipped with sophisticated instruments capable of detecting these biosignatures. Perseverance is even collecting rock and soil samples that will be returned to Earth by future missions, allowing scientists to study them in greater detail. The discovery of definitive evidence of past life on Mars would be one of the most profound scientific discoveries of all time, fundamentally altering our understanding of life in the universe and our place within it. Section 7. Could we survive on Mars today? While the evidence suggests that Mars was once much more habitable, the question remains, could we as humans survive on Mars today? The answer, at least for now, is a resounding no. The Martian atmosphere is extremely thin, about 1% the density of Earth's atmosphere, and it's composed primarily of carbon dioxide, making it unbreathable for humans. The lack of a substantial atmosphere also means that Mars has very little protection from harmful radiation from the sun and cosmic rays. Temperatures on Mars are also extreme, with an average surface temperature of about minus 63 degrees Celsius. That's minus 81 degrees Fahrenheit. These temperatures can fluctuate wildly, plunging even lower at night and during Martian winters. These harsh conditions mean that any human presence on Mars would require advanced life support systems, protective habitats, and specialized suits for venturing outside. While technologically challenging, these obstacles are not insurmountable, and the dream of humans walking on Mars is very much alive.